Hello, welcome to MathFarm. Here you are going to see different kinds of videos of computer and maths. If you like this video, if you find it interesting, if you get different new information, then please like, comment, share, and subscribe. Thank you. So let's move on to our topic, that is computer languages. So we will start with our regular languages that we are using in our day-to-day life. So language is a medium of communication which help us to communicate with each other. So this computer language is also having the same purpose, as we will go through with the points and I will explain it. So language is means of a communication through which people interact with each other. Similarly, a computer language is also means of communication, exchange information between user and computer. So without the language without the medium, we cannot communicate with the computer. And to have the communication with the computer, we have to understand its language. Like suppose we are in different countries. So as it is not our native language, we cannot communicate with people of that country because we don't know their language. But once we understood, we can easily communicate with it. Same goes for computer also. A computer follows a set of instructions or programs written in computer language to perform a specific job. So these set of instructions will have particular task. Suppose I wanted to add two numbers. So there, to add two numbers, I have to get the data, two numbers, operation, then I have to follow the process, and then after clicking equal to sign, I will get the answer. So that is a specific job and it is not always similar. Each instruction have different kind of jobs. Each computer language has its own specific rules called syntax. Like in our languages, we are using grammars, the sentence formations, the patterns, words are different, but the idea behind it is always same. So in computer language also, so rules are little bit different. It is known as syntax, but the main logic behind it is always same. Programming languages have been developed over a year in a phase manner, and that each phase is known as each generation, which makes our work user friendly and easier to use and more powerful. Each phase is improved, made in a development of a programming language, and it is referred to as a generation. Programming language in terms of their performance, reliability and robustness can be grouped in 5 different generations, and that 5 different generations also we have categorized that we are going to see next. So the 5 generations are first generation, second generation, third, fourth and fifth. It is also by using their short form we can write 1GL, 2GL, 3GL, 4GL and 5GL. So now we will see their classification. So these 5 generations are categorized in two groups, low level and high level. Low level in that first generation and second generation, high level third, fourth, fifth. So we will see that in a short description. So the first generation is a machine language. So as we know that the first language that we are learning or we are able to speak, that is our mother tongue. So we can say machine language is a mother tongue of computer that computer can understand directly. Then the second generation, assembly language. Third is high level language. All others are also high level languages, fourth and fifth. But in that, compared to the third, the fourth one is very high level language. And the fifth one is artificial intelligence language. It is also known as, it is close to the human languages. And it is easy for humans to understand also. So before starting to understand this concepts of generations, we need to understand the concept of language processor. And why we need to understand language processor, as I previously explained you, that computer can understand machine language, that is its mother tongue, and it is in the form of zeros and ones, that is also known as a binary language. So computer can understand this language, but the second, third, fourth, fifth generation languages are not understood by computer directly. It has to be a processor which will process this second to fifth generation, fifth generation languages into a machine language. So a language processor is a system software that converts a high level language program into a machine language program for computer to execute it. And to execute it, it has to be in a machine language. So we are going to see here three language processors: assembler, compiler, and interpreter. There are other language processors also there, but these are the processors that most commonly used. So the first one is assembler. This is used for assembly language. An assembler is a language processor that converts an assembly language program into a machine language program. Each instruction in assembly language is used to convert it into machine instructions. The mnemonic codes used in assembly language means the short codes that converted into machine language. And the code written in any other programming language, either it is in a second, third, fourth, or fifth, it is known as source. And the code in a program, in a machine language, it is known as object code. These two concepts you have to understand: source code and object code. So the code in a machine language, it is object code, and other than machine language, whichever language or whichever generation code it is, that is a source code. Next, we are having compiler. So compiler is a language processor that converts the high level language program into machine language program in one go. As they say, one go, that means they will check all the program together, and at the end they will give the errors from it. It first scans the entire program and then translates it into the machine language. Compiler also lists all the errors in the program along with the line numbers on which errors have occurred. So they will also show us errors, and along with that, at what point or at which line the errors occur. And until we clear that error, it will not proceed it. The translated program on the object code produced by compiler is stored in the computer and can be used to execute the program in future. Next, we have interpreter. So interpreter is a language processor that converts a high level language program into machine level language program line by line. This is the main difference between compiler and interpreter. In compiler, as we see, it will check, as we see in compiler, it will check whole program together, and at the end it will give the errors. But in interpreter, line by line it will. So suppose I have a code of 5 lines, and in third line I am having error. So if I am using interpreter, so in interpreter it will stop working at the third line. When we correct it, then it will move for the fourth line, then fifth, if it is error free. Otherwise, if it is having error, then it will be there, it will stop there. But in compiler, they will check whole program together. It reads the line of source code, converts it into machine code, and executes it. If there is an error in the code, the interpreter waits for the error to be corrected before proceeding. As I explained you, that before proceeding, it has to be corrected. The object code produced by the interpreter is not stored in computer. It is generated each time the program is executed. It will not be stored. Whenever you will run the program, it will be executed. So this is a flow diagram that we have. So any high level program needs compiler or interpreter to convert that particular program into a machine language program. Now here we will stop our video And the next part, that is the description of generations, that we will see in our next video.